Hello and welcome to my first FreeCAD tutorial. So I'll start out with a disclaimer. I'm not an expert of FreeCAD by any means. I've just recently gotten into FreeCAD by watching some really great content on YouTube. So a big shout out to Delta Hydra and Mango Jelly Solutions. Both are in the comments. I've linked them. And there's a few things that I figured out myself by piecing together that info that I wanted to put into my own video. I hope that it's still useful for someone. It certainly is useful for me because sometimes it's easy to forget these details. So in this video, we are using FreeCAD 1.1, which is an amazing improvement, like no comparison at all to previous versions. And you'll see I'm using Linux here, but the same should work on Windows as well. And what I want to do is to create a parametric pipe. So pipe is a very simple machine element that I routinely use for pretty much everything that I weld together. And these pipes typically have 45-degree angles. Sometimes they have. Sometimes you do a butt weld and then they don't. And sometimes you angle them, for example, by constructing a frame out of steel. You want 45-degree angles there. And I want to model this in a parametric fashion, and I'll show you how to do this in FreeCAD in a very satisfying manner. So let's start out here, right? So the first thing that I always do is I save my document. Let's call this parametric pipe. And we go into the part design workbench, and we start out by creating a sketch. And we create that sketch on the YZ plane. We want to have a rectangular pipe. So that rectangular pipe, the feature I'm going to use is a centered rectangle for this. And we put the center of that center rectangle in the origin of that coordinate system. And now look on the right side, we have two options that are both very useful for us. We want rounded corners because a real steel pipe always has rounded corners, so it's never completely rectangular. And we also want a frame. So we could construct a centered rectangle and construct an offset geometry, but FreeCAD also does that for us when we say we want a frame. Let's dimension this part. Let's say it's 40 millimeters wide, it's 30 millimeters high. Now it asks us what the corner radius is. Let's say this is 1 millimeter. And it also asks us the thickness of that part. And here we want to dimension that on the inside. That makes it easier for us later on because that also means that the width and height is always the outer dimension, which is just more useful for us. So we'll say -3 millimeters here. And you'll see we already have a fully constrained sketch. So that's very nice. But you'll also note that we have just regular values, right? So 1 millimeter radius, 40 millimeter wide, 30 millimeter high, and 3 millimeters thickness here. We want to turn that into parameters as a first step. So I'll close the sketch here. And then in the body, I'll click this icon here, which is variable set. This adds a variable set. I don't add any properties for now, but this variable set is where I'm going to store all the properties that influence how that pipe is constructed. So let's rename this variable set, give it a label, call it configuration, and then revisit the sketch and double click, for example, the height here. And now we click the FX button and we say store in variable set as height. And we do the same for the width. We go to FX, store in variable set, and call it width. We do the same for the radius. FX, store in variable set, radius. And the same we do for the thickness of the part. FX, store in variable set, thickness. Now what you'll notice is that we now have a fully constrained parametric sketch. So when I go back to the configuration, you'll see all these variables have appeared here. And when I change any of those, you'll see that the sketch immediately changes as well. So I've changed those values back to the original, and we can now close the sketch. We are already ready to extrude this part. So again, let's click Pad here. Now, one thing I like to do is to keep all these parts centered on the origin of my coordinate system. So I'll extrude this symmetrically. And for the length, I'll say this is 750 millimeters. Again, I'll click this FX button here, store in variable set, and call this length. You'll see that now we have a 3D body. We have a 3D body that already represents the part, and we have also the length as a variable that we can now change. And you'll see that the part immediately changes. We can also change the geometry, right? So we can change this to 70 millimeters. So now what we want is we want to add angle cuts to this pipe. We want to add 45-degree angles here. And so as a disambiguation, let's maybe rename this sketch the base feature sketch, and then create a new sketch. So let's select the front face of that part and say new sketch. This attaches the sketch to that face of the part, which is not what I usually would want to do. I would usually want to put that sketch on the XZ plane. In this particular case, however, it's more useful to have it actually aligned with the face of the part, because that means the geometry of the faces after the cut here, they won't be cut in the middle, which makes things simpler once you get to assembly. So anyways, I zoom in here. I first pull in external geometry. So we say external projection, and we take the top line here and the bottom line here. That's actually all we need. Now we can disable showing the part, and we can select both of these and turn them into construction geometry. Now we want triangular cutouts here, right? So we want to pocket essentially a triangle like this, and we might pocket a triangle like this here. So to create the features that we later want to pocket out, we'll just use lines. We won't use a triangle geometry here. We connect those 2 points first, then go from the lower one to the upper one. If we hover over the construction geometry, you'll see it'll automatically create a coincident constraint, and then back to the original point. You'll see we have 1 degree of freedom left, which is exactly the angle of that triangle. And we've said we want this to be 45 degrees. So we click this line, click that line, and then we say dimension, angle dimension, 45 degrees, and it's fully defined. You can imagine if we pocket out this triangle now, then we get a 45-degree inward angled pipe. But we also might want to create an outward angled pipe. So we add another line here that goes from the upper face to the lower one and back again. And again, we have that 1 degree of freedom left, which we take away by clicking this, control clicking this, and adding an angle constraint here, saying this 45 degrees, and that's done. Now we do the same on the right side. Line between the outer points, from the lower point up and back. Create an angle constraint here. And a second line from the upper point to the lower and back. Add an angle constraint, and that's done. Now you see we have 4 rectangles here, fully constrained sketch, and we can pocket those out of our pipe. So let's do that now. So we'll hide the pad first. Makes it easier to select this. Select our first triangle, show the pad again, and then say pocket. You'll see where the pocket would be created. you can see this is a one-sided pocket and we want this through all. And you'll see that we have now created our first outward 45-degree angle here. Now we also want to do the same thing with the other triangle. So again, we go to our sketch. Let's rename that as well while we are at it. This is the pocket sketch. And you can see we've cut out the lower part. So now we want to cut out the other triangle. We select these three lines. We show the pocket and we pocket again through all. And you can see that now we have a pipe that's angled in both sides. Now the trick we are going to be using to make this parametric is, now you'll see we have two pocket operations after each other. But each of these can be suppressed. So if we suppress that one, we get an outward angled pipe. If we suppress the other pocket, we get no 45-degree angle at all. And if we just suppress this one, we get an inward angled pipe. And we can make that parametric as well. So let's first rename these features so that we can disambiguate them easily. Let's show none of them first and then enable the first one. We'll see this is the outward pocket on the left side. So let's call this left outward pocket. And this one is the left inward pocket, meaning that if we show this, we get an inward angled pipe. If we show this, we get an outward angled pipe. And if we show both, then we get a pipe that's angled in both directions. So essentially we just need to repeat that same process with the right side. We already have our sketch. Let's go to the front again. Let's show our pocket sketch, hide the part. That makes it easier to select this. Control click the lines, show the part, pocket. Pocket through all. Okay. So we have the outward pocket created first. You can already rename this. This is the right outward pocket. And then again, show the sketch, hide the part, control click the lines, show the part, pocket through all. Okay. Now also rename this feature as right inward pocket. We can suppress both for now. And we can see if we enable the right inward pocket, we get an inward angled pipe. If we enable the outward pocket, we get an outward angled pipe. And on that right side, you can see that this face here stays intact no matter if this pocket here is enabled or if that feature is enabled. That face is never split in the middle, and that's important for assembly later on. So that's great, but we want to make these pockets parametric. For this, we first go back to our configuration. We right click here and say add property, and we call this left angle. And we select a property enumeration, and as values we say this is none, inward, outward, or both. You can see that I've added this here now, and we can obviously do the same thing for the right angle. So we add a property and have the values none, inward, outward, or both. Add this. But you'll see, obviously, those don't do anything yet. From the viewpoint of FreeCAD, this parameter now has an integer value. It's either 0, it's 1, 2, or 3, depending on what I've chosen here. So now what we will do is let's go to the left outward pocket and think about when we need to suppress this. So let's think about the inverse, right? So when do we not want to suppress this? When do we want to cut this feature? We want to cut this feature when it's either an left outward angle, or if it's both. So in other words, we want to cut this feature. Let's look at the configuration again. If it's either the value 2 or 3, which means that we suppress it when it's 0 or 1. And we can do this. We can go to that pocket, we can go to suppressed, and we can right click it and say expression. See, right now it's true, it's a constant true, but we can say configuration.left angle equals 0, and now we need to say or configuration.left angle equals 1. So if it's either 0 or 1, we suppress this feature. I'll copy this in my clipboard so I can reuse it, because I want for the left inward pocket a very similar condition. But now we suppress this if it's either 0 or 2. Now let's look at our configuration. Left angle none, inward angles it inward, outward angles it outward, and both angles it to both sides. We do the exact same thing on the right side. So we go to the right outward pocket, right click on suppressed, say expression, and the only thing we need to change here is we need to change from left to right, and down here as well. The same thing for the right inward pocket, right click, expression, and here 0 or the value 2. Now let's verify that this worked. Right angle, inward, outward, or angle to both sides. Now you can see that pipe is already fully parametric. This is exactly what we want. So we can vary the length, we can vary the shape, we can vary the angles. But the name of this always stays body. So there's one last final touch that we want to do, is we want to be able to automatically name this to be the pipe that we've actually created. And this is also possible in FreeCAD, which is really nice. We can make the label of this body parametric as well. To do this, let's click on body and see the label. The label is just the text, right? So if we change this to foobar, it becomes foobar. But you'll also see that this is a function. So we can enter a function here. And you can see that we can use, for example, foobar, and we can add to this string. We'll make this an explicit string. We can say configuration.length, for example. Now you see it says cannot convert string to quantity result. That's obvious, so we need to make this into a string. Now the pipe would be called foobar 300.0 millimeters. This is not really handy, right? So first of all, millimeters are always implied, so we can divide our length by 1 millimeter. Now we have foobar 300, which is better, but still not ideal. So let's say we always want to show just the rounded millimeters. And for that we can use the Python printf format expansion. Now this is one part of FreeCAD that is really, really ugly in my opinion, but I'll show you the syntax and I hope that will make sense. So we can name our part pipe, and then the first value we want is actually not the length, it's the width. And we want to show that width. And we can use a printf formatter. We'll use %.0f. This means we want a value that's a float value, that's the f, and we don't want any values after the decimal point. And now we'll have to use a % here and add that value here. You see that's a pipe 40, and we'll say x 40 times %.0f, a second value. Now we want the height. Now in Python you could just use a comma and put the height after that value. This doesn't work in FreeCAD. We have to explicitly use the tuple function. And now you'll see that pipe would be called pipe 40 times 50. And we can just iterate on that times. And now we also want the thickness of that pipe. (40 times 50 times 3). Now we want a dash and we want the length of that pipe, which we also can just add like that. So now it's a pipe 40 times 50 times 3 dash 300. What's not shown yet is the taper. And we could just, for example, add a decimal value here by %d and say configuration.left angle. So this is the left angle, and you'll see 0. As I mentioned, this is a decimal value. But that's not very handy, right? What would be more useful for us is that if it were inward angled, it would show an I. If it were outward angled, it would show an O. If it were not angled, it would show an N. And if it were both, it would show a capital B. We can do this. It is going to be ugly though. So what we will be using here is, since we can't create an array and index that, as far as I know, the expression editor just doesn't allow for this. We can use the ternary operator for this. We say %s here. And now we can say if the left angle is 0, question mark, then we want to show a n. Otherwise, and now let's just show an x here. Just to verify that this works, put this in brackets. Now it should show an n if the left angle is none. It should show an x otherwise. Let's verify that this works. So we go to our configuration. You'll see the pipe is now called 40 times 50 times 3, 300n. And we do the left angle to inward and it renames it to x, right? Now we don't want x. We want, as I've said before, the appropriate letter here. So let's go again to the body and change that function. We can just nest ternary operators. And this is, I'll admit it, this is really ugly, but as far as I know, there is currently no better way to do this. So we'll just copy this expression and put it on the else side here. We'll say, and I'll put this in brackets here, just for clarity. If it's 1, it's inward angled. And now again, copy that expression here. If it's 2, it's outward angled, otherwise it's both. That's the only remaining option. And now this should work. So now we can go to the configuration. We set the left angle to inward angle. You can see this becomes a capital I. Outward angle, capital O, both B. And now obviously we just repeat the same thing for the right side. So we copy, we put a %s just after the first %s, and we copy that whole condition here, put it after that, and just change every occurrence of left to right here. And now that should behave as we expected. So now it's BI, so on the left side it's angled in both sides. On the right side it's inward angled. BO, BB, or BN. So by that you can now have a fully parametric pipe that can be angled in a 45-degree angle depending on what you want. And it's very easy to create parts this way once you've set it up once in a template. So please let me know what you think. I'm very curious to hear your thoughts. I'm very sure there's better ways to do one or the other thing. If you do know shortcuts that I've missed, please let me know how to do this maybe in a more efficient or easier way. Thank you very much for watching that video and have a nice day.